Architect Divya Chakravarti. She completed her undergraduate studies from SRM University and she went on to pursue her master's in historic preservation and urbanism and study of the built environment from the University of California, Los Angeles. She went on to work for the Department of Planning and Preservation for the city of Pasadena, California. She also did a brief stint of work for Historic Scotland, Edinburgh, UK. She had also worked on conservation projects like Khalsa Mahal, Gokhale Hall in Chennai, and Marimalappa Educational Trust in Mysore. She is currently working as a director of Samrakshan Heritage Consultancy. She is also a co-founder of the Artisan Reprisal of Traditional Materials, Method and Technology. She goes on to conduct workshops to revive traditional and lost methods of construction.
Welcome to the UGC lecture series for Bachelors of Architecture. The subject we are discussing is environmental science. The topic we'll be delving into is environmental pollution. In this lecture, we'll be looking into environmental pollution and its different types like air pollution, water pollution, soil, marine pollution, noise pollution and thermal pollution. If you look into environmental pollution as such, pollution is the effect of undesirable changes in our surroundings that have harmful effects on plants, animals as well as human beings. Pollutant, anything that is solid, liquid or gas that causes pollution is called a pollutant. So, example of pollutants are lead, sulfuric acid, carbon monoxide. Types of pollution: degradable, non-degradable. Degradable is those that can be readily broken down by natural processes. Example, discarded vegetables. Non-degradable, those that cannot be degraded by natural processes. Example, plastics. Now, types of pollution we will be discussing: air, water, land or soil, noise, thermal and nuclear. Now, types of sources. So, you have point source and non-point source. Point source is single, identifiable source like a drain pipe, a smokestack. We can identify it to one particular point of origin. Non-point source is dispersed a source. So, you cannot trace it to one particular part or factor. Runoff from pesticides, fertilizers. This could be from hectares of land and it cannot be said that this is the source or point of origin. Non-point sources, like I just said, it could happen anywhere. It could be runoff from the industries, it could be from soil fertilizer, it could be from rivers that are carrying it from upper levels of the mountains and any of this. So, when you test this water now, it could be polluted. But to point and say this water is polluted because of this factor is not going to be possible. This is the point source where you can actually see the point of origin and say that this and this industry is causing so much of pollution and it's discarding so much of effluents. The effluents can also be measured either in gaseous or in liquid state. What are the key environmental problems? Population growth, resource use without preventing pollution and reducing waste, degrading habitats and reduction of biodiversity, poverty, failure of government to encourage earth-sustaining economic development. The Paul Ehrlich formula or equation, this is impact equals population times affluence times technology, where I actually is the impact on the environment resulting from consumption of mankind, P is nothing but the growing population and A the consumption per capita, that is affluence, and T is the factor of technology. So, all of this is multiplied and that gives us the final impact. Now, if you look at the atmosphere, gases that envelop the earth are held here by gravity and that is what regulates the temperature at different parts of the earth. So, the major gases that you have are 78% of nitrogen, 21% oxygen, 0.9% of argon, and 0.03% of carbon dioxide. There are trace amounts of water vapor that are close to the surface, 0.01% by volume near poles to about 5% near the equator, and many others like hydrogen, neon, helium, krypton, ozone, and methane. If you look at the composition of air, like we discussed, majority chunk of it is nitrogen, taking a whopping 78%. Next we have oxygen taking nearly 21%, and the others, which encompasses argon, water vapor, carbon dioxide, methane, krypton, hydrogen, ozone, everything is a 1.4%. Oxygen is what we need the most because humans consume oxygen, and at the same time oxygen is required for combustion, and the gas that is released as a result of combustion is carbon dioxide. So these are the different layers of atmosphere. You have the troposphere, the tropopause, stratosphere, the stratopause, mesosphere, the mesopause, thermosphere and the thermopause, which leads to outer space. So it ranges from about 7 to 10 kilometers to a whopping 500 kilometers. So exosphere is right above towards space, and this is the most important component, ozone. That is the one that protects Earth and people of Earth and different animals and plants of Earth from harmful radiation of the sun. And ozone occurs between stratopause and tropopause, that is significantly the stratosphere encompasses the layer of ozone. So that's average around 80 kilometers from the surface of the Earth. The layers of atmosphere, troposphere is about 75% of mass of air, 17 kilometers thick, a turbulent layer of rising and falling air currents. Stratosphere extends up to 50 kilometers above the Earth's surface. It's obviously less dense, contains nearly 99% of remaining atmosphere, similar composition that is. Ozone has a higher volume here. Water vapor has a lower volume, calm air, very little vertical mixing. Mesosphere is about 50 to 90 kilometers and thermosphere 90 to 110. The stratospheric ozone layer, this is formed by natural processes produced by O2 interacting with lightning and UV radiation, absorbs most of the shorter wavelengths, that is UV radiation, which is damaging to living things causing cancer, sunburn, cataracts, etc. And this is the one that allows life to permeate on Earth. And ozone depletion is nothing but a reduction of the ozone layer, and it's a result of pollution of different kinds we shall see in the future. What are the major sources and types of air pollution? The presence of one or more chemicals in the atmosphere in sufficient quantities and duration to cause harm to humans, animals or plants. Because of pollution, you can see these trees and plants which are planted across the highway and the median will be drooping and brown because of the constant exposure to exhaust. True that plants do consume carbon dioxide for photosynthesis, but the percentage of exhaust that comes out from a constant flow of vehicles surpasses the consumption of carbon dioxide by the plants. And the secondary factor is the exhaust contains much more harmful chemicals than just carbon dioxide. Air pollution results from human activities such as burning fossil fuels, that is oil, coal and gasoline, to create electricity and power automobiles, and manufacturing industrial products such as chemicals and plastics. So the typical air pollutants are particulates, hydrocarbons, carbon dioxide, carbon monoxide, nitrous oxide, nitrous dioxide and sulfur trioxide. So these are sources, could be automobiles, industries, etc. The increased carbon dioxide in the atmosphere contributes to the warming of the global climate, so called the greenhouse effect. The increased chlorofluorocarbons, that is CFC, in the atmosphere has been depleting the stratospheric ozone. CFC used to occur in most refrigerators, coolants and even those aerosol products that come under pressure, it could be anything from a shaving foam to a deodorant, used to have CFCs. CFCs were a major component to have things under compressive pressure. It is only with advent of technology, and we have realized that CFCs are quite harmful, that this has been replaced. Sources of air pollution. Typical natural sources are volcanoes, fumaroles and hot springs, decay from marshes and bogs, increased ozone due to thunderstorm and fires. Man-made, which are considered most severe for human health. Stationary sources, those that are fixed in one particular location, that is point sources like we saw, smokestacks from industries. 14% air pollution is from plants generating electricity. Fugitive sources, that is construction sites, exposed areas. Area sources, that is dense urban community or agricultural area. Many of us might think, how does an agricultural area actually contribute to pollution? But with new methods of agriculture, that is tractors and everything that is mechanized, and all of these machines use diesel, the level of pollutants is far more severe in these areas. Mobile sources, those that move while polluting. So these are basically your automobile industries. 60% of air pollution comes from motor vehicles and 80 to 80% in just major cities. So you can see whopping 60% from jets, industries and commercial uses, and 40% from automobiles. Major sources of pollutants: 38% to 40% from cars and trucks, 21% from household and other products, 23% from non-road engines, that could be your jet fuels, it could be boats, it could be anything, and 18% from manufacturing industries. What are the main categories of air pollutants? You have primary, those emitted directly into air like sulfur dioxide, carbon monoxide, nitric oxide, nitrogen dioxide. Secondary, those that form as a result of a chemical reaction of the primary pollutant with a natural component of the environment. Examples, some ozone or sulfuric and nitric acids. Types of pollutants: primary pollutants and secondary pollutants. Primary pollutants that are emitted directly from identifiable sources produced by both natural events or human activities. Dust storms, emission from vehicles are typical examples. When certain chemical reactions take place among primary pollutants, so that is sulfuric acid as an example. Moving on to typically primary pollutants that we see: carbon oxides, that is carbon dioxide and monoxide, nitrogen oxides, sulfur oxides, volatile organic compounds that are hydrocarbons, suspended particulate matter. Auto exhaust: hydrocarbons, methane, butane, propane and others. Hydrogen sulfide, H2S gas, which is extremely toxic. Particulates visible, that is dust, smoke, soot, very fine, which is lesser than 2.5 micron meters. Lead batteries, additive to gasoline, becomes airborne and it spreads to the land as well. Primary air pollutants: sulfur dioxide or SO2, it's a colorless, odorless gas. Particulates of SO4, which combines with water to form acid rain. It's toxic to plants and animals and it causes severe damage. Carbon monoxide is also colorless, odorless gas, readily combines with the hemoglobin in blood, extremely toxic again. Nitrogen oxide, NO nitric oxide, nitrogen dioxide or NO2, this is a yellow brown to reddish gas converted to nitrates in the atmosphere, causing acid rain. Photochemical smog, this is nothing but brown air smog. Smog is smoke plus fog in the presence of moisture. This is usually seen in urban areas where, because of pollution and the weather at that point of time, it lay as an entire layer, blocking and creating a lot of respiratory issues as well as visibility issues. Photochemical smog, this is a kind of air pollution originally named for the mixture of smoke and fog in the air. Hydrocarbons and nitric oxide reacts in the presence of sunlight to produce ozone and PAN, which is peroxyacetyl nitrate. Nitrogen oxides plus hydrocarbons plus ultraviolet radiation leads to PAN plus the creation of ozone. The effects of photochemical smog: breathing ozone results in respiratory distress and severe headaches. It damages plants, and photohydrocarbons causes polynuclear aromatic hydrocarbons are extremely carcinogenic and cancer causing. This is a typical photochemical smog like we discussed. It usually happens only in urban areas where there is a severe pollution crisis, especially caused due to vehicular pollution. What are the effects of air pollution? The effects of air pollution ranges from reduction in visual range and atmospheric clarity, less contrast and less visibility. This not only pertains to road transport but also to air travel, which can cause a lot of disastrous consequences. Damage to vegetation, including leaves, needles, fruit, growth rate, reproductiveness and hardiness. Decline in net primary productivity or NPP. Crop losses could happen anywhere between 1.9 to 5.4 billion a year. Degradation of human health, from mild problems like eye irritation to severely respiratory diseases like asthma, bronchitis, cancer or emphysema. Carbon monoxide, 90% natural, 10% from incomplete combustion. Cigarettes, this can easily combine with hemoglobin and it reduces the ability of blood to carry oxygen. Nearly 150,000 to 350,000 deaths per year is caused due to carbon monoxide poisoning. Degradation of vertebrate health, aquatic life with impacts on respiration, bones, teeth, reproduction, increase lake acidity, decline in net productivity. Degradation of soil and water. When air pollutants settle, toxic metals in soil and soils are leached. Deterioration of man-made structures, breakdown of car paint, roofing, acid rain, chemically dissolves marble statues and other building materials. One of the examples we are aware of in our own country was the acid rain that was happening in Agra, causing the damage to the Taj Mahal, and severe yellowness was noticed. It was only then it was realized that the rain occurring in that area is harmful and certain activities had to be done. Now flights are not allowed to fly right across and above Agra, it has to take a circuitous route, and certain other changes have also been accompanied to reduce the influx of acid rain. Effects of air pollution. Air pollutants can overload or break down the natural defenses such as the hair in our nose, the sticky mucus in the lining of the upper respiratory tract, causing diseases like lung cancer, asthma, chronic bronchitis, etc. Effects of air pollution. Cigarette smoking is responsible for the greatest exposure to carbon monoxide. Exposure to air containing even 0.001% of carbon monoxide for several hours can cause collapse, coma and even death. And that is why it was later discovered with a number of experiments that air-conditioned rooms should not allow smoking, and even if the filter system has to be regularly changed for the same practice, because if the filter is not clean, then any carbon monoxide leak that is there could cause drastic consequences. Carbon monoxide gets attached to the blood hemoglobin and reduces the oxygen carrying capacity of blood. This then impairs perception and thinking, slows reflexes, causes headaches, drowsiness, dizziness, nausea and blurred vision. Nitrogen oxides and suspended particles both can irritate lungs, aggravate asthma or chronic bronchitis and increase respiratory infections. Many volatile organic compounds such as benzene and formaldehyde and toxic particulates such as lead and cadmium can cause mutations, reproductive problems and cancer, breathlessness, irritation of eye, nose and throat. Sulfur dioxide irritates the respiratory tissues, Chronic exposure can cause bronchitis. Sulfur dioxide also can react with water and oxygen and other materials to form sulfur containing acids. These acids can become attached to particles which when inhaled are very corrosive to the lung. Chronic exposure to the leaves to air pollutants can break down the waxy coating that helps prevent excessive water loss, and this leads to damage from diseases, pests, drought and frost. It also affects photosynthesis, respiration and other metabolic activities. Doubling carbon dioxide. In 1850, atmospheric carbon dioxide was about 280 parts per million or ppm. Today, it's about 350 ppm, and this itself was in 2000. So, now nearly 16 years later, it could be much more. This increase is largely due to burning of fossil fuels and clearing up of forests for human needs. Oceans and also photosynthetic organisms in the oceans currently absorb half of the carbon dioxide that is emitted. So, you can see there has been a steady increase in carbon dioxide levels from 1960 to 1990. From 320 it has reached 360 ppm. Concentration of carbon dioxide also, that is parts per million, and versus the concentration in 1990, it has steadily increased, and in spite of us knowing that it is steadily increasing, we are unable to do anything because carbon dioxide is a byproduct of most of human activities, versus the only solution for it is growing more plants. And the main problem for that is deforestation, because man needs more and more land for the growing, to accommodate for growing population, and at the same time he needs more vegetation to satisfy the needs of this growing population. So, it kind of becomes a vicious circle. This is to discuss the carbon dioxide cycle. You have carbon dioxide in the atmosphere. Through diffusion, it becomes carbon dioxide in the oceans. Then you have the calcareous sediments like limestone and dolomite, aquatic biomass that is taken, and then you have plants again on the topsoil which consume the CO2 in biomass, and then through photosynthesis they release out, and the process of respiration it is released out, and that again is absorbed by the oceans and other water bodies. And another source of carbon dioxide is fossil fuel burning. So, even though the sources of carbon dioxide is many, the only way it is absorbed is by plants and by the aquatic biomass. So, you should realize that the process by which carbon dioxide is generated is much more than the absorption rate. Impact of increasing CO2 levels in the atmosphere. Increased photosynthesis and productivity by Earth's vegetation. Increased plant production also means increased respiration. Elevated atmospheric CO2 means global warming. Elevated carbon dioxide means an increase in global temperature or the greenhouse effect. Global temperature may increase by 30 degrees to 40 degrees by end of the next century. Elevated CO2 means an increase in global temperature which actually leads to greenhouse effect. Global temperatures can actually increase from 3 degrees Celsius to about 4 degrees Celsius by the end of the next century. Greenhouse effects. Greenhouse gases or GHGs. Some greenhouse gases occur naturally in the atmosphere while others result from human activities. Naturally occurring greenhouse gases include water vapor, carbon dioxide, methane, nitrous oxide and ozone. Carbon dioxide is a product of burning fossil fuel as well as wood. Nitrous oxide or NO2 is produced by fertilizer use and released from decomposition of animal waste. Methane CH-4 is produced by bacteria from sediments, swamps and in flooded rice paddies. Chlorofluorocarbons or CFCs, freon, a refrigerant, deplete the ozone layer in the upper atmosphere. Halons such as halocarbons are released from fire extinguishers. Water vapor in clouds radiate heat back into the earth. So, when all of these are contributions of greenhouse gases, right from water vapor, which is naturally occurring, and then carbon dioxide, which is because of burning of fossil fuels and consumption of other such fuels. If you look at the increase in greenhouse gases, there's a steady increase. Everything has steadily been increasing. The parts per million, if you look at carbon dioxide, it has reached 360. And here we have in methane. CFC, even though it started in only post 1900s because it's basically only in aerosols and refrigerants, it has still had a steep increase in a century. And nitrogen oxide, even though steady, in the past few years has steadily increased. Greenhouse effect. Carbon dioxide and other gases allow light to pass but trap heat in the atmosphere, much like glass in a greenhouse traps heat. This greenhouse effect is thought to be responsible for global warming. Carbon dioxide contributes to only 56% of the greenhouse heating. The average surface temperature of Earth is around 15 degrees C. Global warming is increasing in the average temperature of the atmosphere, oceans and land masses of Earth. This is the typical greenhouse effect, where you have solar radiation is reflected by the Earth and the atmosphere. Earth's surface absorbs some radiation, is absorbed, and then it uses it for warming it up, and some is re-radiated back because of the presence of water and water vapor. Then what happens in the atmospheric level? Infrared radiation is emitted by the Earth's surface that has been absorbed from the solar energy, and some of this infrared radiation passes through the atmosphere. Some is absorbed by greenhouse gases and then re-emitted in all directions by the atmosphere. The effect of this is basically to warm the Earth's surface and lower the atmospheric temperature as well. Impact of global warming: causing temperature extremes, that is rise in sea level and change in precipitation, injuries from storms and coastal flooding, interruption of water supply, contamination of drinking water, drought, food shortages due to shift in agricultural food production, air pollution which is made worse by warming, asthma, bronchitis, emphysema complications, strain on public health systems, increased need due to population migrations, unable to contain the spread of infectious diseases because of uncontrollable migrations as well as airborne diseases. How do we know that we are causing global warming? Less heat is escaping into space, there is rising temperatures, more heat is returning to Earth, there is a pattern where ocean temperature is increasing, more fossil fuel carbon in ocean, more fossil fuel is being noticed in corals, more fossil fuel carbon in trees, and nights are warming faster than the days, and winters are warmer than the summers. It's leading to the melting of the ice caps, and upper atmosphere is reducing and cooling, shrinking of the upper atmosphere. So, all of these factors tell us that global warming is happening. At the end of this lecture, we have looked into environmental pollution. The types of environmental pollution we have covered is air pollution, the causes and effects of air pollution. At the end of this lecture, we should be able to answer the following questions. What is environmental pollution? Define the term pollutant. Discuss the different types of pollutants causing air pollution. What is greenhouse effect? How does it cause global warming? That brings us to the end of this lecture. Thank you.